Okay, hi guys. My name is Alison. I want present you my particular project about Wiegand protocol, and I want discussion about control access and other topics involve Wiegand protocol also. Yeah, basically I will show you that, and let's go. Okay, first of all, I need to talk about the agenda. Basically, I want to discuss some concepts and about Wiegand layers. So how can I get the signal, what the Wiegand cards and Wiegand format to applications. I think it is very important talking about that, about implementations and Wiegand setup, and finally the future plans. Okay, first of all, I'm talking about the basic concept. I think is everybody knows what is RFID, but the question is, what it means RFID? So RFID basically it is acronyms to radio frequency identification, but this technology uses the wave to identify and track. So basically, these two words is very important, I think, because we identify something for some purpose, and track also, so we can have activity tags and to track and around the environment. So yeah, this technology is very common today. And yeah, other question I bring this presentation, it is, what is necessary to have a RFID operation? Basically, we need three components. So we need the reader and antenna and tag or transponder. So yeah, reader, as you know, it is basically read the data and send some place, some host. Antenna basically receive the signal, they produce and receive the magnitude, and tag, I won't show it also this, what is this tag? But basically tag can be anything. Can be the card, or can be used a key, for example. Yeah. So what is reader? Reader is basically send and receive RF signals to or from antenna and extract the tag number. Well, the tag number, it is basically what really want. The tag number carries the access to our environment, or a particular access to the system can be used, for example. Is usually connect a third-party system that is accepting and storing RFID related event to trigger actions. Well, the third part can be anything too. Can be this university, for example, can be office. So there are many, how can I say, there are many possibilities. Can be the third part. Almost part is inside the system, and we can manage this code for access the environment or access the system. So can be anything. Yeah. Okay. Well. We need to know too. We have a different frequency. So each frequency have a limit range. So the frequency starts 125 kilohertz and have 10 centimeters to range. So we spend little power, but when you want more range, we need to spend more power, of course. Well, so most application, not most application, but each application have some necessities to each frequency, for example. So if you get the 20.45 gigahertz, we have 100 meters. So basically we can communicate a difference in different points. So it is very useful for track some objects inside the buildings, for example. So the tags, now talking about the tags, we have three types of the tags. We have activity, semi-activity, and passive tags. So the basic is very easy. Is very easy to understand. So activity and semi-activity tags use a battery, but activity tags you can be transfer and receive signals. So we can have a communication. When I want talking about a receiver. So also can be the story that can be stored some data. For example, temperature, humidity, can be anything. But this is small piece of data. It's not large data as you can imagine. But this tag have a high cost. So we need to pay attention about that because the cost, most of the applications is very important. We need to have attention about that. And can be used in long ranges. So yeah, we can use it to tracking and monitoring and in certain periods of the day, for example. So it's nice to have that for tracking, basically. Semi-activity also just receive. Semi-activity sometimes it is used to data storage too. Also have the high cost and works in medium range. So semi-activity, not almost part it is on. So we need to pay attention to that because the semi-active tags works in some deep sleep periods. So yeah. And passive tags is more common. Maybe I think most of we have a passive tag in our wallets, for example. Maybe have one. And yeah, basically work is in low frequency and no data storage. It is just an antenna inside that have a little chip, and works in short range, around in maximum 30 centimeters, basically. Well, about the Wiegand layers. So I create these layers. So it is important for me. It's very important to understand because we have the low layer and high layer and the middle layer, basically. So the Wiegand interface, it is a low layer, which basically is it is a standard common user to connect a reader to the rest of the access control. Above, we have the Wiegand effects. Basically, Wiegand effect, it is how exactly the transfer data works. So we can how it is encoder and decoder information, and the protocol. It is the part one I really discusses in this presentation because protocol is very important. It is which you use almost part for the application. So the protocol prescribe how to connect the wires and send information to the card reader to access control. So these protocols carries many information. This protocol carries the facility code and ID codes. I will discuss that. Well, Wiegand signal. So Wiegand signal is very simple architecture. So we just have three wires. We have data 1, data 0, data 1, and the ground. When we connect to the system and reader. So data 1 and data 0 signal are held at logic level until the reader is ready to send that data stream. And other point, it is important, data 1 and data 0 pulses will not overlap or occur in simultaneously. So yeah, basically we will not see the buff signals down or up in same time. So it is that. And here we have a table to how can the data works actually. We have when data 0 is low, data 1 is high, and the result it is 0. When data 0 1 and data 0 1 and data 1 0, we have the 1. If the data 1 and data 0 it is the same level, don't care. So the signal is not valid. Well, about Wiegand cards. So Wiegand cards was a sweep type, can be embedded in wires, but nowadays it was a long time ago. It is very common for credit cards, for example, or other applications involve the cards basically. But today, the proximally and contactless smart cards using an embedded radio frequency integrated circuits. So basically, RFID substitute this contact. So now we can just use the Wiegand protocol, and we see a Wiegand card, SIP card, and now we can see the Wiegand. Also, it is a RFID card. Use RFID. Okay, about protocol. So this protocol utilize simple binary code. When I say just two signals, and we need to compare the signals basically, the two data lines, data 0, and data 1, and a ground. So the first bit and last bit are used to parity bits. Basically, we need to confirm that there are any errors when we transmit the data. And the most common is the 26-bit forms. In this protocol, we can have two different behaviors. We can have you can use most significant bits or least significant bits, but most applications using MSB, most significant bits. Okay, this table I want to show you. It is very important because in internet there are many we can be confused because this value is not quite right. We don't have a standard basically, so it is important to share with you because the facility code, we have the facility code and ID, and we have reserved 80 bits. When we use 26 bits, we reserve 80 bits to facility code and 26 bits to ID code, and also 2 bits for parity. So we have even and odd parity. Well, facility code is important because it is the first part, the frame, which is very important to the system, to the reader. It is identificate who the system who pertains to this system, basically. Okay, and application. Well, I showed this 4 application. Maybe there are more application actually, but nowadays is very used into tracking and park managing, access control, and vehicle access. So it's very common. Well, now I want to discuss how I implemented this driver, and it is a work in progress also. And well, I started to get in my ESP32 device kit and use GPL interrupting, configuring fail edge. I use a parity check, and I supported two formats, 26 bits and 34 bits. Sorry about that. Okay, about implementation, I want to discuss. It is quite simple. It's not big too much, but I create a trigger routine. So I wait a trigger routine come to the GPIOs. So I trigger GPIO interrupt when change IO signal. Basically, I check the IO level, so I need to check the data 0 and data 1. And if the signal level is different, it's the same, if different, I increment the buffer, but if not, if the same, I ignore this value because it's maybe not value, is not value. Okay. Okay. Now after that, I separe the facility code and ID number, and also I build the ABA code. ABA code is basically the result, the sum basically into the basically sum with the facility code and ID number. So this yeah, basically the sum. Yeah, and now I will discuss the setup. Basically, the setup, we need to go to the system types and check the GPL interrupt. Okay. After that, we need to go to the device drivers. After selected Wiegand support and select which Wiegand support we're using. Now I will using 24 bits, but we have 34 bits, but we have 26 bits to also we have support. After that, we need to go application configuration, examples, and Wiegand examples. Okay, yeah, and in future, I want to give more support to Wiegand formats, and also I want implementation custom length fields. So we have in some projects the fields can be changed. Some facility code can be short, for example, 8 bits, and we have more bits for the ID card because we need more variety these codes, and create example to simulate Wiegand sender. So now we have a reader, but it's good to have sender because some case we need to simulate this behavior. Right? Yep. And I did support to keypads. Also, some keypads using this protocol because it is very easy because we have just 2 wires. No, 80 wires, for example, to read the rows and columns. Okay. Well, I want to show you guys this application works here. So yeah, I want to show you, but I need.
There is some assistance to.
Yeah, please. Okay. This is. Oh. Yeah. Thanks, Alan. Oh, I
try to move it near to get the.
Okay, please, Alan.
No, I think it's worse.
Worse? Okay.
It's worse here. Yes. You need to. No. Can you see?
Maybe not.
No. It will delay a little bit. Because the new falar por aí. Foi a vida.
Okay. Nice. Okay. Okay. Now we have inside the Nurex. So let me check. Okay. Here we have the example Wiegand. So I type in Wiegand. And okay, the app is running, and this demonstration, I using this device, which it is basically using to lock and unlock some doors, and I use this card or RFID card, and yeah, I put here, and voila. I have the ABA code the FC facility codes and ID codes. So I can extract these values, and after I rebuilding the ABA code, which basically the sum between the F code, facility codes and ID codes. There's a short what? No, so
I'm sorry for that. It's my fault, guys. This time not me.
yeah, unlock some bomb.
I didn't touch anything. You pressed it right on time.
Okay, so yeah, thank you guys. I really appreciate your time, share your time, and thank you for these opportunities. For me, it's very relevant. So thank you everyone here, local and online too.
Okay. It's okay?
Yes, it's the same.
Okay. Thank you very much, Alison. It was a really great presentation. Take care. Thank you. And I'm very happy that you did it. Actually, Alison implemented everything in the Wiegand very fast. He sent me some videos, show, it's working in the oscilloscope, and he was very excited when everything worked. So I'm glad that Alison did it. Thank you very much, Alison.
Thank you. Okay. Any question?
Do we have any questions here locally?
Please.
The ABA code. The ABA code is like a checksum for the card ID? Or?
No, it is just a sum using the facility code. And this complete information, this complete frame, basically.
Okay, so the ABA is a random number.
Yes, basically, yeah. Basically a random number because carries the facility codes. Inside that we have facility codes and the ID card.
Okay, so both are the ABA.
Yeah, both is related to the card.
Perfect.
So, but we sometimes need the ID card for recognize some IDs, for example.
Okay.
Inside the system.
Thank you.
Thank you, Lucas. Okay. Anyone else?
Anyone else? Okay.
Yeah, please.
Please say your name and.
Hello, my name is Marcio. Congratulations for your presentation and your application. May I ask you if did you implemented that application in form of an application or a device driver more an application?
It's more device driver application.
Okay, good. Oh, thank you very much.
Thank you, Marcos. Okay.
Okay, guys. Thank you very much, Alison. Really great presentation again.
Okay.
And so I think we can move to the next speaker.